October 2nd, 2018 will be remembered in Pennsylvania weather history for quite some time. During the afternoon and evening hours, a record-setting 14 tornadoes ripped through the state, affecting areas from the far southwestern corner of the state all the way up to the northeastern portions of the state. 4 of these tornadoes were rated EF2, while 6 of these tornadoes were rated EF1 on the enhanced Fujita scale. I sat down with PhD graduate student Branden Katona with research specialties in mesoscale meteorology to talk about the rarity of this event and what caused all of these tornadoes to form.
In terms of rarity, it's pretty uncommon to see that many tornadoes on any October day in Pennsylvania history. I believe I saw the statistic that we had more tornadoes on October 2nd than we had in any October day combined for the last 50 or 60 years, since 1950. So we've pretty much outpaced all of the other October tornadoes together just on this one single day. It's actually the 4th largest tornado outbreak in Pennsylvania's history, behind 3 other pretty notable tornado outbreaks, June 1st and 2nd in 1998. Both were pretty substantial tornado outbreak days, and then the famous May 31st, 1985.
The Storm Prediction Center says that Pennsylvania has less than a 10% chance of seeing a tornado in the beginning of October, and there are a few factors that contribute to the low probability of a tornado in the month of October.
In October in Pennsylvania, we just don't tend to see a lot of thunderstorms, primarily because we don't have as many days with rich, moist air masses up in Pennsylvania in October. So this October in Pennsylvania has been characterized, with at least in the first half of the month, by relatively warm and humid air masses occupying most of the state. So it was just kind of waiting for a day with sufficient shear and mechanism to initiate storms, really to spark an outbreak like this, and that's what happened on the day. On October 2nd, there was a weak shortwave trough passing overhead in the mid levels of the atmosphere. And associated with that was a speed max. The speed max allowed for sufficient vertical wind shear to organize the cells that would occur later in the day. There was a weak cold front that was also drifting through Pennsylvania that day, which provided a mechanism for lift, and there was also a prefrontal trough ahead of the cold front that also allowed for some storms to form ahead of the front as well, which led to some of the extent of the outbreak in terms of it wasn't just focused along the front, it was actually over most of Pennsylvania on that day. And then we had quite a bit of instability as well. So when you have a warm and humid air mass in place, there is the potential for a lot of instability to occur. And we had lapse rates in the mid-levels of the atmosphere that were just sufficient enough to have about 1,000 to 2,000 joules per kilogram of CAPE, which is definitely more than sufficient for supercells.
CAPE, or convective available potential energy, is the positive buoyancy of an air parcel and a good indicator of atmospheric instability, which makes it a very valuable tool to predict severe weather. I noticed that many tornadoes were also lining up one right after another during the tornado outbreak.
As far as there being multiple supercells in a line, that's definitely a phenomenon that is rare by any means, especially in other parts of the country. As far as in Pennsylvania, I've seen that a couple of times where you kind of see supercells lining up one next to another. As far as what causes that, it's generally some type of outflow boundary or localized boundary in the winds that allows for supercells to constantly generate one after another in the same area.
With all of the tornadoes in Pennsylvania this year, I was curious if research is being done to increase tornado lead times.
Some of the most exciting research going on right now is the Warn on Forecast project, which may actually at some point allow us to issue tornado warnings from computer model simulations instead of just based on radar. So the hope is that if we can assimilate enough data about the storm into a model, we can run a variety of different simulations that get us potentially up to 50 or 100 different outcomes of what this storm might evolve into, and then we can develop probabilities of how likely this storm is to form a tornado at different times based on the simulations. So we can basically make a plot that says, okay, between these 2 times, the tornado or the supercell is 70% likely to make a tornado, so we'll issue a tornado warning. And so to me, that's kind of the future. But as far as what we can do in maybe the next 5 or 10 years before we get to that point is working on assimilating all of the satellite data that we have. That's something that Penn State is currently doing quite well at. With our data assimilation research group, they just published a paper showing that if we can actually take all of the data that we're observing with our satellites instead of just the couple of parameters that we had been working with in the past, that we can get much better lead time in terms of knowing maybe earlier in the day where supercells are most likely to form and where they have potential to develop tornadoes.
Hopefully these research efforts will help to increase tornado lead times, helping to keep more people prepared and safe for any tornadoes that may impact Pennsylvania next year. For Weather or Not, I'm Jacob Moores.